Hello everyone, I'm Teacher Xie. The course we are going to talk about today is Introduction to Robotics. First of all, we will define the term robot, and we shall use the definition given by Wikipedia. A robot is defined to analogize human behavior or thought. Or you can also say it this way. It analogizes behavior of other living things, such as robotic dogs and robotic cats, etc. Robots can be autonomous or semi-autonomous. We will give some examples to explain this statement. First of all, let's take a look at this part. We can classify them according to their type of labor. If we classify them according to the work they can perform, we can classify them into two categories. The first one is industrial machines. This type of robots mainly replaces humans in the manufacturing and assembly process. For example, the one we can see here is a multi-axis robot made by Highwind Technologies Corporation. It is placed in the production line or in some factories to perform assemblies or manufacturing work. This one on the right is a service-type robot. This robot on this right is the Zambo Robot made by ASUS. Its designated work is more service-oriented. For example, it can be in charge of crowd recruiting job in banks. That is, when a customer comes in, it will do a simple classification. It will ask a few questions and then tell the customer to which counter he should head to for convenience. Sometimes this kind of service can be seen in hospitals. When you go in, if you need to measure your height, weight, or blood pressure first, the Zambo robot can provide you with such service about its labor classification. Regardless of whether it is an industrial robot, it assists people in replacing human behavior to do certain works, such as the Zambo robot. It provides serviceability and conversational work. Next, let's keep looking within the robots. We can classify them based on their moving medium. Some move on land and some move in the air. Some move underwater. First, let's take a look at this type of robots that can move on land. The one we mentioned previously, the Zambo, is a representative of wheeled robots. It uses wheels to move. Another type is the legged robots. It will use 4 limbs or 2 legs to move. Legs are also a commonly used way for moving. We can reference to the Boston Dynamics company. It can be considered to be a leading company in the advancement of legged robotics. For example, this Spot robot has recently been available for purchase. Its price is $74,500 for this type of legged robots. Its main scope of application is on areas that are more rugged. The terrain is more rugged, unlike the places that can be reached by wheeled robots, such as stairs or paths that are more inclined. They are more suitable for this kind of legged robots. Therefore, when it is necessary to perform more complex tasks, it is very suitable for this kind of robot to go to those places to perform those tasks. Next, let's have a look. Land-based robots are roughly divided into these two moving types. Once we are done discussing the moving of land-based robots. Next, let's take a look at airborne and underwater robots. Let's take a look at the underwater robots first. What is most commonly seen at sea is this, the ROV, underwater remotely operated vehicle. The development of this kind of robot is actually very important, especially for Taiwan. Why is that? Taiwan is surrounded by sea. Regarding marine resources, as the resources on land are becoming more and more scarce, the exploration of marine resources will become very important for Taiwan. What is more, the ocean occupies around 70% of the Earth's surface. Therefore, if it is possible for the exploration and gathering of marine resources to be more and more convenient, it will definitely be by means of the ROV. Therefore, as far as Taiwan is concerned, the development of the ROV has much greater importance compared to other countries. After talking about underwater robots, let's talk about the final type, the airborne robots. The ones that move in the air are, of course, the drones, being the most representative from its early application in the military, as well as its use for aerial shots, extending its use for agriculture. Its development is in fact very fast and also very important. Next is the application in the transportation industry. In order to reduce the use of manpower in this area, drone delivery is actually a very important field of development for transportation and logistic companies. After introducing these different types of robots, let's go back and review the definition of robot. Its behavior can be like a human being, such as the multi-axis robot, which can perform assembly and machine types of work and complete such work like a human being. It can also be like the Zambo Robot and act like a human being to interact with other people and assist the humans to solve certain issues related to communication. It can also be like a quadruped robot and mobilize in rough terrains, or also move like fish in the water, or move airborne like a drone. For all these things, in actuality, the development of robots are like the extension of the human limbs and mind to help humans solve certain problems. As long as the development of the robot in a way that is beneficial, humans will continue to make progress to make up for the shortcomings of humans. So there is only one ultimate goal. The goal is to make people's lives more and more convenient. Regarding robots, after you have comprehended their definition, let's give a practical example to let us understand more about this technological field of robots. Let's take the sweeping robot as our practical example. The sweeping robot can be commonly seen in our daily lives, and many households already own such machines. First, let's take a look at the first aspect of sweeping robots. The first is the visual navigation system. It is the most important component. The difference in price for each sweeping robot is due to this component. Why do we say this? Because in our visual navigation system, it is usually divided into two common categories. The first category being imaging, while the second is light detection and ranging. First, let's talk about light detection and ranging. LiDAR uses laser beams to scan the surrounding furniture. Then it uses laser to beam onto any object within the household, which will reflect the light back, and our LiDAR system will receive these signatures and reconstruct a 3D model of the household. It will know where there will be obstacles present and where needs sweeping. The other type uses imaging. How is imaging achieved? We shall explain this to you shortly. Whether LiDAR or this kind of image recognition, it utilizes a technology known as SLAM. Why do we develop this SLAM technology? Because the term SLAM means simultaneous localization and mapping. It does two things. The first thing is localization, and the second thing is mapping. Why does it do these things? First, let's see why is mapping needed. Because it needs to help cleaning the household. It needs a map in order to know from where to start, where to go through, and where to end. But you can all think about this. Do you give a map to your house's sweeping robot when it starts to clean? Of course you don't, right? If you don't, then it needs to reconstruct it itself. So the aforementioned LiDAR type uses laser beams to reconstruct the household's visuals. The imaging type, such as the one we see here, its visuals captures the images of the ceiling. You may think it captures images of the ceiling, but it sweeps the floor. This is because mostly every household ceiling and the floor are parallel to each other. So it only needs to take reference to the ceiling and recall these images. It can probably have a mapping of your household. For the second thing, once it can read this map, the second is localization. When a sweeping robot is in the process of moving around, it will know that it has moved 1 centimeter, 2 centimeters, 3 centimeters. Then it compares the images captured during mapping to serve as image variability during motion. This way, it can know where in this map it is located. Therefore, through imaging and its sensors, it can perform these two things, which is known as mapping reconstruction. That is, construction of the map and its own localization, which positions it has moved to, which areas have already been covered, and which areas have not yet. So it is through this SLAM technology that visual navigation is achieved. For the next part, just having visual. In fact, for some more delicate places, the robot is not able to see, so it needs the assistance from other sensors. For example, you can use an infrared sensor or a collision sensor. When it detects that there is an obstacle in front or the collision sensor is activated, it knows it has hit something and it will pull back and turn around. Another type is the anti-folding sensor. When your sweeping robot is moving, at its front there is a sensor. When it gets to the place where there is a step, the sensor will drop down and it will know that there is a level difference. And then what? It will know that there is a step in front, so it will pull back. So all these are to help make up for the lack of visuals. So additional sensors are needed. Through these two methods, the visual navigation and the use of some auxiliary sensors, it can move around the household. After moving, the next thing is the most important work for the sweeping robot. What is its job? Sweeping. The way the robot sweeps is like the way humans do. Take a look at this robot on the left. It will act like a small broom. It swept this thing. It will sweep in the dirt, and the orange dustpan will collect the dirt. After the dust is collected, the next thing is, by just sweeping, you will probably know when you sweep and the dust is very small, you actually can't sweep it up. What should we do? It can only be done by using the vacuum functions of the vacuum cleaner to suck in the dirt and then pass through the dust filter. These functions, the same as when people are cleaning. You sweep the floor, and after you finish vacuuming, you realize that it is still not enough. Why? Because we still want to have the results of a wet mop. So modern sweeping robots now can have these wet mop results. It will attach one of its used clothes onto the back of the sweeping robot. After wetting the clothes, once wet, it can do the cleaning again. But with the wet mop results, so that the dust that remains on the floor gets absorbed onto the clothes, the overall cleaning results becomes better. That's why it has the wet mop function, and it needs to have a certain degree of control over this wet clothes. So for a sweeping robot, not only it needs visuals but also can sweep and mop. All this is for our household to have a greater degree of cleanliness. The next topic is about its main functions, and of course some additional functions. All these additional functions are to solve convenience problems when operating the sweeping robot at home. For example, the first is remote control using your phone. Why does the sweeping robot needs remote controlling? Because when the robot is carrying out its duties, due to the floor layout, it may have difficulties reaching certain areas. So it has a remote control for you. Using this remote control to command it, which areas have not yet been cleaned or which areas are dirtier, you can command it to clean up such areas. Then the most important point is that when the sweeping robot is cleaning, the owner may not be at home or is probably sleeping and just lets the robot move around. So when the voltage becomes too slow, it will automatically need recharging and will need to return. So through the aforementioned positioning technology, it detects the distance between itself and the charging station, finds the shortest distance, and immediately returns to the station to recharge. Okay, after looking at an actual example, let's take an example we just saw. Group it and classify it. The classification we are going to do for the sweeping robot through our talk about it. During our explanation, you will find out that it has some important components. One is the sensor. It must have an image sensor, an infrared sensor, or a collision sensor to allow it to sense its surrounding environment and then send the feedback to its controllers. These controllers will assess the conditions of the surrounding environment, that is, which parts are stairs and which parts are obstacles for it to avoid, which areas it has already passed through and does not need cleansing anymore. So the controllers need to do these things. Next, what the controller will do is a continuous stage, which is sweeping and mopping, or when it turns out of batteries. When there is no electricity, what does it do? It returns to recharger, which allows it to make movements. Such motors that make the broom move or let the robot move. This is the task of the motors. Or it also starts the vacuum cleaner to clean up dirt. These are the tasks that the actuators have to perform. So next in our course, we will be dividing the topic into several parts, from electronic circuit boards to discussing programming mechanisms and structures. And then, because we want our students to be able to construct their own robot, we will talk about computer-aided design. We will put some design design aspects of the robot onto the computer to design. Once the design is finished, we can send it to the laser engraving machine or the 3D printer to manufacture these components and parts and later assemble them. After assembly, once we put together the software and hardware, we need to make collaborations so that the robot's performance can be better. What we will do in the next part of the course. So the goals of this semester's robots course are these three parts. The first is to develop programming ability for automation to perform data processing and calculation. Taking the example we just had, that is, our sweeping robot, it can use sensors or image sensors or LiDAR to perceive the data of the surrounding environment. These situations will be sent back to our controller, and then the controller will clean according to its initial command input, combining with the data it collected to perform its cleansing task, knowing where there is an obstacle that needs to be avoided, where hasn't been cleaned yet, which needs to be cleaned up. So this is the ability for data processing and calculation. It's the first condition that one must have. Then the second condition is, once we finish our programming, it is still an abstract thing. In order to implement it to the point that it can be operated, of course, it will need electromechanical components to assist it on the execution of these ideas and commands. So it needs a motor to perform the cleansing task, or it needs perspective, its surroundings through sensors. All these need electromechanical components. So the program and the electromechanical components are the combination of software and hardware. Finally, it needs to develop an integrated ability for computational and design thinking. Computational thinking is key for information technology. That is, you need to be able to screen out the phenomena that we see and find out its regular pattern, summarize its principles, then design its algorithms, and then solve the problem. Design thinking is key for living technology. We hope that the students can observe a certain phenomenon with empathy and then find out the needs from this phenomenon, define the problem, use the brain to think about how to solve this problem, and finally make a prototype, make a draft, test out whether this thing can solve the problem. If it can, then we continue with further development. We will continue to develop. If not, we can find another way to solve the problem. It solves frequent daily life problems by means of software and hardware design thinking. For the development of robotics, in fact, the development of robots ultimately is to solve problems of human lives. By means of software and hardware, we can try to develop new technologies to make people's lives more convenient.